all, this is the first Zoom delivery I've done, so I'm a little nervous, and I'm hoping the IT works out okay. So if there is any issues, please let me know. But yeah, hopefully this goes all right. So I'm Nate, based in Sheffield, mainly work in the UK, but also all over the EU and outside the EU. I've been working in the adventure industry for over 20 years, but focusing on the climbing wall world for about the past 15 or 16 years. I've done the mountain training qualifications, or most of them, as well as rope access qualifications. I'm on various committees for technical stuff with ABC, route setting. And then I've designed some products and worked as a technical advisor. But the main thing which I've been doing is running my company, which does all sorts of services for climbing walls, as the name would indicate. So what we're going to talk about today is some of the things that those services might touch on. And specifically, the first thing is the standards. So we're going to look at EN 12572, which is the artificial climbing structure standard. And so it's a little bit dry, but it is pretty important. And it is relevant to what we do on a day-to-day basis, and it sort of affects many things that we might not be aware of in the operation and use of the climbing structures. So a lot of this information is very similar to what I wrote an article on the Vertical Life Route Setter magazine. So if you have a copy of that, it's kind of written out. Peter and myself did that, and that's a pretty good article. That is part of the Spot Prize as well, so you can get one of those. And so we did that, and this is part of the seminar because the awareness is really important. And so as the industry improves and professionalizes, then we are expected as operators and users of the facility in a professional way to understand the Eurocode in which it complies to. So we'll start with that. So the first start is the three sections. There's three sections to the climbing wall standard. Part one, which is the roped climbing standard. Part two, which is for bouldering walls, and part three, which is for climbing holds and volume. So there we go. The first version was released in 1999 with various stakeholders. People realized that walls are developing as a commercial thing, and so they needed to standardize what was going on. And Unterfreeze was critical in development of this. They were very supportive. And as the biggest hold manufacturer and the wall manufacturer, they really supported the initial development of that. So that was a big thank you to them. The next big change was in 2007, 2008, where they introduced the bouldering specific element and the holds. And so as the bouldering wall became a thing, it was also realized that needed to be included. The most recent version is in 2017, and that is in effect now. And then the standards themselves are reviewed every 5 years at a maximum by the commission that oversees it. That commission is made up of manufacturers of the walls, the holds, the matting, some operators, associations that are relevant, and also some third parties like insurers that feed back into it. It is worth noting that the standard in of itself isn't designed for operators or users, and so the terminology and the way it's structured and written can be confusing. There's definitely improvements to be made on it. Then the next review is starting soon, I think, and I think there will be some significant changes, so it's worthwhile keeping on top of that. So we're going to work kind of big picture and go into small picture with regard to the presentation today. In the standard, it doesn't quite follow that format, but I thought this was probably easier to get your head around. So we'll start with that. The structural integrity of the climbing wall itself is obviously very important. And so normally this part of the wall is pretty good. When we're doing inspections or maintenance or anything else, then most of the time isn't a problem, but occasionally it is. But regardless, as the operator, and much of my talk is being pitched to operators of the wall. So as the operator, you do have a responsibility to prove, oh, sorry, there was something to do with my audio, but I don't think that's me. We checked it earlier, so sorry about that. Maybe it is someone else. Is it muffled? Can people hear me?
Hey Nate, you're coming through pretty clear here. So if people are struggling with audio, it might just be a case of putting on earphones or something. I know.
Okay.
Yeah, so sound is pretty good here.
Okay, cool. All right, well, that's good to know. Sorry about that. So with the structure of the climbing wall, there needs to be calculation. So the calculations work out the integrity, how strong it needs to be, and it is also applicable to the loading, so where it is. So if it's an outdoor wall, there might be snow loads, there might be wind loads, all of those things. But in essence, in the standard, there's a formula for structural engineers to work to design the wall to meet the criteria that's been established. So this is really important, and it's also something with older facilities that is sometimes hard to get. So on modern facilities, particularly with the main manufacturers, this is part of their package. This is pretty easy to find. Older facilities, you might not have this, and so this is challenging. So if you don't have the structural calculations, what do you do? Well, you can do retroengineering, and that can be accomplished without too much problem, but it is a big job. And so basically, you need a structural engineer to evaluate what is in place and then compare it to the formula that is in the standard. We have done this for a number of clients. It's not a huge job, but it isn't a small job either. Regardless, this calculation will also include the protection points, how they're designed, how they're intended to be fixed to the substructure, and how the substructure is intended to be fixed to the surrounding building or what have you. So important aspect that the calculations are there and that they've been adhered to when it's been built. So the next thing would be the final protection point. So where the rope goes into at the top of the wall. This could be referred to as the anchor, the top protection points. These are all mean the same thing. This is, you could have a final protection point at the middle of the wall if there is a stepped wall where there's an abseil edge or a multi-pitch type scenario. So it could be either in that instance. So there is definition for that top protection point. Part of that definition is that it needs to be secure. And so this means not a singular non-locking carabiner. And so that's quite important. What we have seen is facilities do want to have multi-use, so lead climbing and bottom rope climbing on the same line. And that does present a bunch of problems, but and it's hard to achieve, but it still doesn't negate the fact that the standard says that you need a secure mechanism for the rope at the top of the wall as a top protection point. So if you don't have that, or if you've adapted the system or what have you, then it's definitely worth reviewing that and making sure that, well, you conform, or if you don't conform, you've justified the non-conformity and you've put something in place to make that okay. What that is, I don't know, but it's worth looking into. So each part of that protection point needs to have a minimum breaking strength of 20 kilonewtons, and that's the entire link. So that if it's a chain, every link of that chain needs to have 20 kilonewton minimum breaking strength. And it needs to be secured to the substructure by two mechanisms, so 2 points. So in essence, your typical V-hang would go into the wall with 2 points, all parts of that system being 20 kilonewtons minimum breaking strength, and then secured on the back with a locking mechanism. So normally that would be a nylock, but it could be a lock washer or something else. So all parts of that system need to be identifiable as well. and they need to be appropriate for use. Now, we'll mention this again, but there's a very distinct difference, and people aren't aware of this, between PPE, like the connectors, and the CE mark, as it were, that's associated with that, and anchor systems, which don't need a CE mark. There's not a way to mark it. You could have components in that anchor system that are marked with a CE mark, but the anchor itself wouldn't necessarily need that, or even able to get that. But it would have an EN marking on it, and also for a unique identifier and its strength rating. So each part of that. You should be able to trace that back to origin, and also look at any sort of user data that's associated with it for maintenance or anything else. The only kind of exemption of that, and we've seen this, historically in new walls as well, is where the manufacturer has designed part of the substructure to extend out to be used as part of the anchor system. This is pretty standard as well in rope access, where you have big steel work. The example of that would be like a belay bar. So it's not really an anchor, it's not really PPE or anything. It's part of the substructure, and therefore it probably wouldn't have any marking or anything else, because it's a big piece of unquestionable steel. So there is a little bit of deviation even in this. So we do occasionally find random things in the anchor system which are not okay. And so this is an example of some random chain, probably bought from like a DIY shop, that someone's installed as part of the anchor system for a wall that was in use. And so we can't really say that's okay, because it's not okay. You don't know how strong it is. Maybe it's really strong, maybe it's not, I don't know. You don't know where it's come from. It's no markings on it. And so it just reinforces the fact that the safety critical parts and anchors in this instance, it needs to be identifiable and fit for use. So I don't think this was. Lead points. So individual protection points protect progress up the wall. This is an example, a drawing of like a spacing calculator that we use when we're doing checking conformity. Any part of those points needs to meet the same standard, which is 20 kilonewtons minimum breaking strength. Also, it will be identifiable, traceable, all the same things that we said about the final protection points will be relevant for these as well. The height of the first space, or first protection point, will be 3.1 meters or under that. And the spacing is determined by a formula within the standard, which relates to the height and the terrain and that sort of thing. Now, the reason I bring that up is in the new standard, the most recent version, that has been relaxed slightly, particularly for higher up in the wall. As the higher you go, traditionally, the further the spacing was. So be aware of that. Now, this is also an area where you will have a blending of PPE and anchor systems, and I'll go on about that quite a bit throughout both sessions. But there is a difference. So PPE by definition is personal protective equipment, and an anchor system is an anchor system. And the difference there is if you have to remove it with a tool, it's not PPE basically, although things can be PPE and non-PPE at the same time. So like a Mayon is a good example of that. Cool. Free space and fall space. So the free space and fall space around the wall and in the wall space is very important for obvious reasons. You don't want people hitting things when they fall up or when they're climbing. And that's the same for both bouldering walls and roped climbing facilities. So the standard stipulates that there needs to be an area to fall into that is free from hazards. In the new standard, it does also stipulate that there needs to be movement of the other people, the public, around the wall, which is free from hazards as well. And I suspect, and it's a little bit ill-defined, I suspect that that's talking about like people landing on them, being lowered or whatnot, but it isn't clear. But in this instance, we're talking about things that are in the fall area, which could present a hazard to the climbers. So for roped climbing, that needs to be free is measured from the line of protection points. And that does move around because, as we know, some of the protection points move around the wall. But it's a corridor, which is 1.5 meters to either side, 2 meters behind, and 8 meters below the protection point. And that shouldn't have anything in it that can cause a hazard to the climber. There is some exemptions. Excuse me. Climbing surface is exempt from that because then you could never have corners. In saying that, occasionally it's worth evaluating if that is a possible hazard. And so some of the older facilities have ledges and then lead climbing above the ledges, which could be a hazard for the climbers. Now, it might be exempt by the standard, but this is where some common sense comes into play, and you have to risk assess the situation. So we have seen that as well. The other thing that's exempt is a non-hazardous wall that can hold the impact of a climber. So they phrase that a little bit differently in the standard, but basically like a blank wall that can take the impact of the climber hitting it wouldn't be considered a hazard. And that's good because in the previous standard, it didn't stipulate that. So even a blank wall would be problematic according to the standard. Now, these problems really come to light when the wall has been retrofitted into an existing building, like a church, an industrial building, anything else, in that it wasn't built for purpose. So there isn't a lot of free space, and there might be other problems in there. So what do you do? Well, it depends on what the hazard is and how high of a risk level it could be. Ideally, you move it and get it out of the area, but that's not always possible. So you could clad it with climbing surface, both with bouldering or rope climbing, that would work. You could pad it if there's something like steelwork directly above the top of the line, and someone could stand up and just gently hit their head. Maybe just putting some padding on it would be okay. Or you could roof set to make sure that climbers can't come close to it, therefore they're maintaining their free space. Signage maybe is appropriate for low risk, or reducing the type of climbing in the area to inherently reduce the risk level. So no lead climbing. If there is a ledge at half height, it's not a bad idea. Whereas perhaps it depends what the ledge is, depends on rope stretch, that if bottom rope to top rope climbing is okay. But all these things you need to know about, first of all, and then work out some sort of process or procedure to mitigate the risk and justify the deviation to the standard. In bouldering, we do see some of the older walls where they're sort of fit into tight spaces where there's some very obvious hazards. So steelwork, cubby holes, storage areas are all possible hazards. If someone falls off the wall and hits them, then that's not good. And it would be difficult to justify why you're allowing climbing in that area. Cool. Climbing surface. So this has evolved, as we all know, extensively from brick holes in the wall, which have been removed, to or real rock inserts, which again seems to be a thing for some reason. And when I first came to the UK, the first walls I climbed at were of this type, and I can't say I'm sad to see them go. The amount of like dead skin and stuff stuck to the old greasy holes is pretty disgusting. But it's taken some big steps forward with regard to the climbing surface. So they might be fiberglass, they might be resin, it might be concrete, it might be brick, it might be plywood. All sorts of things can be the climbing surface, but they do need to meet the standard regardless of what they are. So the reason this has been put out is because of failures. And so panels, either when people land on them, from swinging into them while rope climbing and going through them, or the panels themselves ripping off. And so in the standard, there is three major tests. So one is an impact test. And so you orient the panel, you drop the weight into it, and you see if it breaks, basically. And if it breaks, then it's not good. There's a deflection test where you have a sample size, you load it, and then you measure the deflection. And then the other one is part of the insert test, where you're testing the combination of whatever the hold fixation point is with the surface and making sure that it is strong enough. Where we see problems with this is with older GRP walls, like fiberglass walls. There's one or two particular styles which are very bad, which I won't discuss, but they're obvious. So they're heavy flex, lots of cracking, and they're very questionable. The other thing is when with cheap thin plywood. So if plywood is not the right grade and consistency, then it is weak and it won't pass the test. And we've seen that when we've done testing. So again, with any of this area, it would, if you bought your wall from a main manufacturer, if you're running a wall that has been built that way, you've probably got a handover document which says all of the conformity, all of the testing references and that sort of thing. If you don't, then you might need to do something to get that, because you would be expected to justify conformity or not. And so these are all parts of that. And we'll talk more about that in a second as well. So in addition to the strength of the wall and all these points here, it also needs to be free from hazards. So these hazards are two main things. One is an entrapment hazard for fingers, like degloving, and that is gaps of a certain distance. This comes from a playground standard, and it's basically you don't want to stick fingers into constricting sharp gaps, like which are presented on the older rock walls, because you'll have possible deglovings or other things. And then you also need to avoid sharp edges, and those sharp edges could be presented by foreign objects like steelwork. The wall itself, if it wears, like if a rope is rubbing over a feature, it could create a very sharp constricting edge, or things like broken screws, rub strips that have worn, or just are sharp, or anything in there. So all of those things should be removed from the surface and shouldn't be there in the first place. So part of it is design, part of it is maintenance and wear and tear on that one. So with the climbing surface, we obviously have the climbing panel insert. So this is what the standard refers to as T-nuts, or whatever you want to call them. So they can come in lots of different forms. There's hammer-ins, there's screw-ins, there's resin-in inserts into direct fixings, there's resin-in inserts with screens. There's all sorts of various configurations of this. Regardless, they should meet the standard if they're in a climbing wall. What they're testing in the test is the combination of whatever you're using for an insert and the surface in an isolation pull test. Now, this is one of the big changes from the previous standards, in that it's more than doubled the required strength value. So it went from around 5 kilonewtons to around 12 kilonewtons. And that's 12 kilonewtons may seem like a lot. It is a lot. But there's a reason for that. And the reason is there are a lot of failures. And so over a lifespan of a wall, that surface is going to be stressed repeatedly. It's going to degrade, maybe it gets damp. And so there's a margin of safety in here with that 12 kilonewtons, which I think is a very good idea, because we've seen many of these fail. Now, just because you're using your surface is good doesn't mean that the insert will meet the test. And so again, when we've done testing or inspection work for different types of inserts, they don't all meet the standard. And so we've got some points about the audio, but I think from what people are saying is that this might be localized to whoever is doing it, because other people can hear me just fine. So it's worse if I take the headphones off. So I don't want to do that. So sorry about that. Okay, so with regard to the T-nut, so just because you're buying a T-nut from someone that's selling you it's a T-nut for climbing wall, doesn't mean that it's going to meet the standard or does meet the standard. So this goes back to the documentation, and that you should be asking this question: does this meet the standard? In testing, hammer and T-nuts, the generic kind, don't. So we had like a 20% barrel shear rate where the thread bit ripped out of the rest of the T-nut. And so that's not good. So it is important to, again, classify the origin of any part of the wall, make sure it meets the standard, and check that, basically. Cool. Now, in saying that, just back to the inserts, they do degrade over time as well. So if they're corroded, if they're stressed repeatedly, you may have a problem. So if you suspect there is an issue, you can do a sample analysis of the inserts to find out if there's a problem with either the surface or the inserts themselves. Cool. Okay, moving into safety flooring. So safety flooring for roped walls and bouldering walls are two different things. Although sometimes they do blend together. There are roped walls that have bouldering mats underneath it if there's a dual use facility. However, for roped climbing facilities, there isn't a standard. So there is not a standard for safety flooring. There's no requirement for it. Now, I think that there will be. I think when it is reviewed in the next couple of years, that this may be instituted as part of the standard, because it's logical. And certainly if you've done any accident investigation, or if you've been involved with any of that, if there is a facility that does have climbing, safety flooring underneath the rope climbing, and there's a deck, it is really important that that is there, because it does stabilize. Rubber crumb stabilizes, definitely. So there isn't a requirement, but it is certainly the industry standard to have something underneath your rope climbing facilities for most of the European countries. Not all. There are some countries that don't have it. I've been into facilities in Switzerland that just have concrete floors. And I think going from facilities that have nice rubber crumb tiles to concrete floor, you do feel it. You feel a little bit unnerved that there is nothing there. So even with rope stretch, it'll save you minor injuries. So what do you use if you want safety flooring? Well, it depends. If it's a short wall, maybe something like gym tiles, interlocking tiles could be okay. If it's maybe it's not. Maybe if it's a higher risk area, perhaps maybe there's more chance of hitting the ground. You should probably use something that's rated, like a rated safety surface. So generally, that will be either rubber crumb tiles or soft core tiles under most facilities. Both of those will have a critical fall height, and so that critical fall height is pretty important. But what we have seen as well in testing, so in the US, they did testing from 14 meters, 15 meters, with different depths of safety surface that were rated. And regardless of what they were rated to, the thicker it is, the better it performs from a high height. So, and that's sort of obvious. If you've got 100 mil rubber crumb, it's probably going to be better than 25 mil rubber crumb. But it is interesting to relate that even though the critical fall height might be the same, the thicker material generally is better for high impacts. So I would recommend, certainly when we're doing inspections or any sort of consulting work, we always recommend some sort of safety flooring. There are instances where it's not possible. If it's a multi-use sports hall, maybe they have articulated mats, and those may or may not have a fall rating on it, but it's certainly better than nothing. With bouldering walls, there has been big development in the modern standard for safety flooring, and this is a big change. So previously, to 2017, there was a definition of what it should be like, basically uniform fall surface, no gaps, and meeting the climbing surface, and a few other things projection-wise. But in the modern standard, there is a criteria of performance, And so this is for manufacturers, and it evaluates three things. So it's deceleration, its deflection, and its resilience. And so the deceleration evaluates the G forces going into the material with an indenter. The deflection is how deep it goes into the material by a percentage. And then the resilience is to do with like the rebound. And all of those things work together to meet this criteria or not. It's difficult one because on an inspection point of view or a check point of view, this isn't necessarily relevant. And so it is vague. And when we talk about inspections and maintenance later on, or if there is any questions on that point, it is a little bit vague on that. So I do accept that. There are lots of configurations of safety foam for bouldering walls, mixed layers, PVC top, carpet top, everything out there. Regardless, this should conform to the standard. The standard's been there since 2017. Manufacturers should be providing you with some sort of evidence that it does meet that standard. In addition to meeting the standard with regard to the performance, it also needs to meet the standard with regard to projection. So how much mat extends around the bouldering area. Now, this does change quite significantly depending on the height of the wall and the angle of the wall. So, but generally, it will be between 1.5 to 2.5 meters to the side and 2.5 meters to the rear of the most projecting part of that area. So it will change throughout the facility, which does making it quite difficult. If you add volumes, big features, or other things, just be aware it does change that projection. So if you've got a macro volume onto a big overhang and it sticks out further than the top of the overhang, or let's say it's vertical, then it will change the required projection of those mats according to how far the volume or holds or mixture stick out of the wall. In addition to the projection, there need to be no gaps, it needs to be in good condition, and there's a few other things, but this is sort of obvious. So we have here some testing we've done, hopefully this works. Multimedia is not my best, but this is some testing we've done in-house with some testers we're developing. And so that's an example of a drop test. Inside there's an accelerometer, measures G-forces, measures speed, and then relates that to a data processing software. But you basically drop a big weight onto some mats. Okay, so holds and volumes. So with holds and volumes, they are part of the standard, and this has evolved quite a bit. Certainly with volumes becoming more popular, bigger, this has evolved recently with the standard. Now, part of the reason, the whole reason for the standard isn't quite obvious, and the reason for the standard is to help with breakage, so that there isn't any large bits of hold that fall from the top of the wall and land on people. It's not just about breaking and someone falling, it's about debris and the dropped object hazard. So when you look at the standard and the tests that the standard have, sometimes they don't make sense. And I would say they're not perfect. The last version is better than the previous version, but it's definitely not perfect by any stretch of the imagination. But it is getting better, and it continues to improve. So hopefully the next version will be better than this version, but it is that. But there is an EN standard for climbing holds and volumes. So the standard with holds is limited in a certain way. So any screw-on holds, regardless of size, are not included in the standard, which is bizarre. Like that's just a really obvious omission. They're also, if they're below 100 grams, they don't need to be tested. Otherwise, there'll be a percentage of the range that should be tested what's tested is worked out by a ratio and formula, and then they do like a strength test. There's a heat and cold cycle, and there's a resistance to fixation test, and all sorts of stuff for the holds. But regardless, you should have evidence that they meet that standard. Older holds, now this is where it's probably expensive and difficult, which is not a good combination. Older holds are partly the problem. So the old resin holds, where there's a very thin amount of resin securing it to the wall, so the bolt's quite deep, are the problem. And so some of the designs, there might be a washer, and that creates an area of weakness that extends out all the way around the hole. So in essence, you've got a thin piece of resin with a washer that delaminates and has this massive resin hold, which could drop onto someone from 20 meters up in the air and kill them. So that is a real high risk hazard, and that's why the standard has been developed. I'm not aware of any deaths by hold failure, but it's certainly, everyone that's done a lot of climbing indoors is aware of holds breaking, and so you don't want any big chunks. So volumes are a new part of standard. They were referenced in the previous standard in that they were a thing, and there were certain criteria about it, but there was no performance requirements. So in this standard, there is. So the surface of the volume needs to meet the same criteria of the climbing panel requirement. So with impact, insert resistance, deflection, all of those things are the same for climbing surface and volume panels, regardless if they're fiberglass or if they're plywood or whatever. So that's important to know. They also need to meet a structural integrity requirement for their fixation to the whatever they're being secured to, and also the way that they're put together. And so what it is it's loaded in a pull test scenario, and to see if it meets the strength requirements. This area of the standard is not good. And I think that the threshold for the forces is far too low. And so I suspect that in the next revision, it will be at least doubled. So if you've got volumes that are meeting this standard now and they're barely meeting it, then it is likely they won't meet it if the standard is improved. But this is obviously a good idea. So this is a picture of a volume we were testing to failure. So just to see what it failed at, and it was well beyond the threshold stipulated by the standard. Pull tested through this through the T-nut there until it ripped apart. And I think it was around 5.5 kilonewtons, give or take a little bit like that. But the standard threshold is 2.4, so which is very low. And anyone who's worked out like forces and that sort of thing, 2.4 in this scenario is not enough. So I suspect it will be increased significantly at some point. So documentation. So this is the really tedious bit, but it's also a really important bit. So there's no point in doing all that other stuff to make sure your wall conforms, but then you don't document it. So just be aware with the Q&A stuff that that's not going to come up until the Q&A section. So if you're putting questions in there, that's great, but it's not going to get looked at until we get to that section. So the documentation. So you do need to have evidence that your facility or your wall meets the criteria stipulated in the EN standard. So from the manufacturer, if it's a main manufacturer in a modern world, you would have all of this already, so it's very easy. If it's a self-build, if it's an old build, you might not. It doesn't mean you don't have to have it though, so you might need to investigate, develop, and do it yourself. So in essence, marking, you need to know which standard it complies to, who manufactured it, the standard it's been manufactured to, what version, the date of install, and also the date of the next main inspection. Additionally, the manufacturers need to supply a user data or instruction manual, and that would include all of that stuff I just mentioned, as well as the details of the protection points, the maximum amount of people that can use the facility at any one time. And this is important. It's a minor point, but it's actually really important, particularly on things like top out boulders, for example, or steep comp walls. And what we've seen is that with huge macro volumes, lots of big resin volumes, many climbers, and then if there's a comp and there's people sitting on the top of the wall, you're probably getting quite close to or exceeding the stated loading of what that structure should take. So it's worthwhile knowing exactly what you can do. Now, I don't think anyone is going to go around and weigh the holds as they put them on the wall. So how valuable that is, I don't know. But having a good idea is good. So if you know it can take all the holds and 20 users, then great. But maybe don't put that like 4-meter macro volume on it as well, because it looks cool. So the what else we got? It also talks about the usage restrictions. So if there is an articulating section of the wall, what can that be used in conjunction with? Maybe there's limited access or something like that. Any maintenance of aspects of the wall, and inspection requirements, which we'll get into in the next section. So now, not everyone's facility is going to conform to all of these standards. And actually, I would go so far as to say that there is not a single center that meets all of these standards. There is always something, whether it's a hold that doesn't conform or something major. So what do you do? Well, if it's not intended, then that's one thing. The first thing is you need to know about it. So you need to know where you conform and where you don't conform in order to make a plan. How do you find that out? Is either in the design stage, and so when you design the wall, you're aware of those nonconformities, you put in control measures to deal with it, or after the fact, you've done some sort of evaluation, compliance evaluation, or it might come up on your main inspection. If you've got competent people completing the main inspection, then they're not there to do a compliance evaluation, but if they're good, they will probably pick up things that are obvious. So important things that may be outside of the standard. So what can you do? Well, you might need to rebuild something. You might need to adapt the structure or change the way it is. Or maybe you can do something procedurally. So first thing would be to do a risk assessment, look at what control measures can be instituted to deal with that nonconformity, and then monitor that really. So can you restrict access or usage? Maybe you don't want lead climbing if there's a depth ledge in the middle of the wall. Group control, if it's a supervised facility and there are certain control measures in place, maybe you don't let them go into certain areas or what have you. Or route setting to allow or not allow climbers into areas with restricted map projection or possible hazards. So all of these things could happen. Now, you have the other side of it where there is intentional deviations. And so this would be where someone has made a bouldering wall that's much higher than the standard stipulates, so like a psycho block. And then what have they done to allow that? So they may have special landing surface, like so they've gone out, they've investigated falls from that height, and they've come up with a process to allow people to climb on that within reasonable level of risk. Maybe additional vetting of who takes part in that activity or how to fall from that height. Other thing is that's becoming more popular as well is rooting roofs. And there you have where the matting may track with the angle of the climbing surface, and you have potential, quite unlikely, but quite big fall potential. And so what have you done to mitigate that? But anyway, you need to know about this, and then you need to come up with a plan to enable usage with a reasonable precaution. So yeah. So anyway, well, in conclusion, I think we're about on time as well. The standards are there to help you, really they are, even if they don't seem that way. But you do need to understand what they are, how they apply to your facility, and keep them under review. So get to know them or get help to know them. Okay, I think that's time, if I'm not wrong.
Yeah, I think pretty much bang on, Nate. I was a bit slow getting to the start after our little issue. So there's some really good questions coming in on the Q&A, and if anyone has more questions as we're going through answering these questions, just use the Q&A and we'll try and get to them. So first question, Nate, the new standards based on the new version of the standards, do older walls now have to conform to these standards and inspections, or can they keep being inspected to their original standard when they were built?
Well, in the standard, it specifically says that it's not retroactive. However, that doesn't mean that you can just ignore this modern standard. So as I said in the final section of non-conformity, just because something doesn't conform, this isn't legislation, this isn't regulation. So you have no legal obligation to conform to it. However, in a case of litigation, if it obviously does not conform and you've done nothing to prevent an injury, then that would be difficult to defend.
Okay, thanks, Nate. And this next question, retrofitting dyno fixings, which I think somebody mentioned, also known as insert nut, to old walls with broken placements. And when you can't get to the back to replace properly, it's not acceptable. What are your thoughts?
Okay, so this is a specific thing. So people who don't know, Dynafix are a insert which threads in from the front of the wall, and they are dependent on lots of factors. So the plywood or whatever surface you're putting into needs to be very good in order to give it its strength. And even at that, I don't think there's any chance that it's going to meet the 12 kilonewtons. So maybe if you do a risk assessment and you decide that for that foothold on the vertical traverse wall, it's probably okay, but on an overhang at 18 meters, that would be very questionable. So it depends is the answer to that question.
Next question. Are there any standards for safety flooring relating to traversing walls of the type you see in many school gyms?
Yeah, so any traverse. So if you look at playground standards, which are much more robust than climbing wall standards, and there are more legal implications of that, it doesn't matter where play equipment is. Now, traverse walls in of themselves may not be play equipment, but they would very likely fall under the same criteria for safety flooring. So in that, if I remember correctly, and I could be slightly off, so if the feet don't go over 600 millimeters, there is no requirement for safety surface, although a very good idea. We'd always recommend safety surface, but there's not a requirement for it. If they go above 600 millimeters, then there would be. However, there's a few things that define traversing, and so traversing along a rope facility would be with it, like you'd have to start being very, very careful, because what the difference between a traverse wall or a bouldering wall is arguable. So again, it depends.
Okay, super. Next question. What are your thoughts on homemade wooden or resin holes? Any standard requirements or considerations to be aware of?
Doesn't matter where they come from, they still need to meet the standard.
Okay, short and sweet. Question on cleaning of holes. Cleaning of holes by running them through a dishwasher. Does that compromise their strength in any way?
You'd have to talk to the manufacturer. I believe there's a heat treatment after holds are manufactured to give a hardening. But on certain holds that certainly like polyurethanes that might heating them up might cause problems. So you need to talk to the manufacturer on that one.
Okay, thanks, Nate. What are the requirements for alterations to a wall built to older standards but altered now? Do we work to original standard or new ones? Are there any implications for a wall being altered like this?
Yeah, so anything that happens after a standard is implemented needs to meet that standard, the modern standard.
The standards you talked about, are they UK specific or do they apply to other EU countries? And then the second part of this, are wall inspections mandatory under EU regulations? What policies stipulate this? So 2 parts.
So these aren't, no one stipulated BS EN standards in any of this conversation. Specifically, we've said EN standards. So these are not the British standard, they're the European standards. So they're relevant in all European countries. The British standard, from the last thing I've read, have adapted the UK have adapted those standards to be relevant in the scenario. There is no change between them that I'm aware of. However, they are standards, they are not regulations, and there are 2 different things there. So there you go.
I think if you want to get a copy of the Ireland specific ones, you go to the NSAI website and you can get them there.
Yeah, I don't believe there's any difference with them. If they're the same number, they will be the same.
Do joints and flooring have to be covered or just no gaps?
What's that? Sorry.
Next question. Do joints in flooring have to be covered or just no gaps?
Well, I would say inherently, if there's not a joint, there is. Yeah, there is. So in bouldering or in non-bouldering?
Let's go with bouldering.
Okay, so in the standard, there is a specific criteria for the joints of bouldering mats. So yes.
Okay. Next question. Does a wall have to have a space behind it for maintenance?
It is recommended there is access for maintenance, but it doesn't stipulate what that is. So it depends on the design of the build. To modern standards, there should be access to the substructure facilitated in the design, but that could be saying, well, you go over the top. It depends on the individual situation and how the structure of the wall is developed, but you don't necessarily need access to do to every aspect. There are other ways to inspect walls depending on what's required with the individual construction style.
Okay. A question on pinning of holes. What is the situation with pinning holes to prevent rotation?
Okay, so that's not, so in the previous standard, there was an anti-rotation test, which talked about secondary points of fixation. That has been removed from the standard in that it acknowledged that you would be expected to attach the hole in accordance with manufacturer's guidelines. So that, what I'm saying is, it doesn't have anything to do with standard. You need to follow whatever the manufacturer of the hold says.
Any practical advice on that?
Well, I would, all right, so when we route set, and certainly if you look at like my RSA hat, we would say follow the manufacturer's recommendation. So if it says you should put a pinning hole in it, then you should put a screw in it. It doesn't always say what that screw is. So I know there's issues with perforation of the climbing surface and other things. But some people, and I'm not saying this is the right thing to do, but some people have chosen to take a risk assessment method for pinning. And so they evaluate the hazard area. So high risk, low risk, bouldering being high risk, maybe the starting foothold on a rope line being low risk. And then decided to pin accordingly to their risk assessment. So I think it's more about justifying whatever you're doing if you are deviating from what the manufacturer or the standard says, and making sure that that's reasonable, and probably discussing that with your insurance company.
Okay. Can holes be modified, for example, drilling for screw fix or filling to smooth off minor damage? Sorry,
well, I think, yeah, so I know I know what they mean. So you go back to the manufacturer. There is not any hold manufacturer that's going to authorize you drilling their holdout because you've intrinsically removed material from the hole. Now, maybe that's acceptable for certain holes. Certainly in the States with the polyurethanes, they don't even come with holes, or they didn't until recently for pinning screws. But that's different. So again, it goes back to that manufacturer. That has nothing to do with the standard. It's to do with contact the manufacturer, ask them if they're going to let you drill their holdout. They're likely going to say no. Smoothing down minor chips around the edges is very different. That's mainly cosmetic, but that does need to be evaluated on a case-by-case example. If it's something more than cosmetic, then you should retire it. If it's cosmetic, then yeah, I don't see any problem in smoothing it down.
Thank you. Any mention of the strength of holes on campus boards?
Well, if it's a screw-on hole, no.
Okay, short and sharp. The next question is, how often do walls have to be inspected, which you think you're going to be covering in the next section?
Yeah.
And I think that's at the moment. Oh, wait a second. There's a few more here. Do protection points have to connect to the main structure? Could a reinforced panel be enough?
Well, you need to go back to the calculation. So there are design builds where they use the panel as part of the substructure. The EP mosaic style is an example of that. T-Wall in Germany does it. But what they do have is an increased substructure to facilitate that, an increased panel, sometimes an increased panel thickness, and certainly an increased number of fixation points. And the hardware is increased to which is used for that fixation. Just simply putting some ply behind a standard piece of plywood fixed to the substructure when it wasn't designed for it totally would not be acceptable.
Okay. Next question, where can we access or download an up-to-date copy of the standards?
Well, you can buy it from BSI. It's about £500.
Yeah, so if you're based in Ireland, it's the National Standard Authority of Ireland. If you go to their website and you can enter in the code 12572, isn't it? Is that it? And you can download the 3 parts, and it comes in 3 parts. And I think they're somewhere around 40 to 50 euros each. And they're pretty, you can get it as a paper copy or you can get a PDF download, and there's kind of some right software on it. But I think as Nate said, unless you're manufacturing them, you probably don't need to have a copy at hand. Because is that a fair thing to say?
Yeah, so they are designed for manufacturers, not for operators. But you should know about them as well. So it's a bit difficult situation, and you should know about the most modern version of them because there are significant changes. So finding a copied one on Google from somewhere that was out of date isn't very helpful, or even if it's in draft version, which I know lots of people have. So yeah, I mean, we have to, every time they come out with a new version, we have to go and spend quite a lot of money to get it. But I mean, that's sort of what you have to do.
I'll put links in the resource packet after the seminar, just to where you can go into NSAI. MI does have a set of copies as well. Because of the right software, we're not going to be sharing them out to people. But if you do have a question and you need to reference something, we're happy to do that.
Yeah, and I think if there's any specific questions after the fact, if people get in touch with Damien, and if there's a number of questions on the same topic about the standard, we're more than happy to share information. There's a difference between copying and pasting you or sharing the standard and giving you the information you need to do stuff.
No question, but just based on side pinning holes that don't have pinholes, that have pinning holes.
So this doesn't really go back to the standard. This would be more root setting practice, and so that is not really relevant to this topic. But regardless of the hold, if there's a high probability of it spinning when loaded, modern holds, there's very few that don't have a secondary point of fixation. Hence why the encouragement to update your hold selection.
Yep. Okay. There's a few little kind of queries just on the standards.
Mm-hmm.
So I'll send out the link to the NSAI site. Jay is asking, if you buy a standard, do you get updates in the future?
No.
Nope. And then I think the last two questions in the queue. How do volumes and large holes relate to the fall space, free fall space requirements of the climbing surface? Do they count as surface or other hazards?
They count as surface technically. But if you put something in an area that is an obvious hazard, so if a swing, potential rope climbing swing into it, or a bouldering clipping it, then that doesn't indemnify you. Like, you would still be, because it's against good practice for route setting.
Okay, and then I think probably the last question we'll take on this. You mentioned a few times using risk assessment for certain things. When using dynamic risk assessment like this, do you record it all?
So a dynamic risk assessment wouldn't be appropriate for this environment because it's a static environment. There are no unknown risks. A dynamic risk assessment would be appropriate for being out on the hill, where the changing environment is unquantifiable. You can't predict every aspect. In a static environment, there is no reason for the most part, there might be, if there's usually you wouldn't use a dynamic risk